A very good morning to all of you. My name is Devanshu Upadhyay. I am from Triveni, Hooghly. I am a science teacher and I am teaching in a convent school for last 10 years. This is my first educational video, and in this video I will discuss on the topic refraction of light. So let's start the topic. Before I start the topic refraction of light, I just want to tell two things as a revision. Number one is medium. Just say there are three types of medium. One is opaque medium, number two is translucent medium, and number three is transparent medium. What is opaque medium? Opaque medium is the medium through which light cannot pass. Example, wood. Example, book. Number two, that is translucent medium. In this medium, the light partially passes. Example, ground glass. And number three, transparent medium. This is the most important medium, that is for our topic refraction of light. What is transparent medium? It is the medium through which light can pass easily. Now, in this topic refraction of light, first I will tell about the definition. Before come to the point definition, the second thing you have to remember that what is light? Light is a form of energy that enables us to see any object. And the most important characteristics of light is that light always travels in a straight line. And this property of light is called rectilinear propagation of light. But in this topic, you all see that there is a change in the direction of the light rays. So, and this change in the direction of light rays is called refraction of light. Now, come to the point definition. The change in direction of light while passing from one transparent medium to another. But, this is the definition. But one thing you should remember, one transparent medium to another, the transparent medium, their density should be different. That means optical density. So here comes the next point, that is optical density. What do you mean by optical density? And why the light bends while traveling from one medium to another medium? Now the answer is the speed of the light. The speed of the light is not same in every medium. It is different for different medium. And the speed of the light is highest in air or vacuum, whose value is 3 into 10 to the power 8 meter per second. Second is water or liquid. The speed of light is near about 2 into 10 to the power 8 meter per second. And last one is the glass or solid part, that is 1.8 into 10 to the power 8 meter per second. So it is clear that the speed of the light is different in different medium, and this is the basic reason why there is a deviation or change in the direction of the light, and this is known as the refraction of light. Now see, optical density. So optical, according to the term optical density, we come two things, that is number one, optically denser medium and optically rarer medium. What is optically denser medium and what is optically rarer medium? We all know that the speed of light is maximum in air. Speed of light after air, the speed of light is less than the air is in liquid part. That is why as the speed of light in liquid or in water is less than the speed of light in air, that is why the medium liquid or water is optically denser than the air or gaseous medium or vacuum. That means here see three cases is there, 1, 2 and 3. Number 1, from rarer to denser. Rarer means suppose it is air. Suppose this one is air. That means light is passing from air, and suppose this one is glass or this one is water. So this is optically denser than air. So here the light rays is passing from rarer to the denser medium. See here, just follow this diagram. This one is the incident ray, this one is the normal, this one is the refracted ray. Angle between the incident ray and the normal, this is called angle of incidence. Angle between the refracted ray and the normal, this is called angle of refraction. And this one, that is interface, this line, this is interface. It separates the two media. That is, here it separates the rarer and denser media. So here some common term or definition you will learn. Incident ray, refracted ray. After that, the angle of incidence. So what is the angle of incidence? Angle of incidence is the angle between the incident ray and normal. And angle of refraction, it is the angle between the refracted ray and the normal. So here, see, angle I, that means angle of incidence, is greater than angle R. So here, in case of light rays passing from rarer to the denser medium, angle of incidence is always greater than angle of refraction. First case. Number 2. Here see just opposite. Here this one is the denser medium, this one is the rarer medium. Here light rays is passing from denser medium to rarer medium. So here see, the light rays is bending away from the normal. And in the first case, while the light rays is passing from rarer to the denser medium, the light rays bends towards the normal. So here angle I is greater than angle R. It is clear. And in case of denser to the rarer, as the light rays is passing away from the normal, that is why angle R is greater than angle I. This is the basic two concept of refraction of light. Number 3, this is also very important. Here see, rarer and denser, same thing. But in this case, light rays is falling at a 90-degree angle to the interface. And as the light rays is falling at an angle of 90 degree, so the light rays will not deviate. The light rays will not deviate, it will go straight. This is the third case. And see here, angle I is, here it is 0 degree. That means there is no angle between the incident ray and the normal. So angle I is also 0. And as the light rays not deviate their way or not deviate their path, that is why the angle R is, that is angle of refraction, is also 0 degree. So these three cases, this is the three characteristics of the refraction of light. Now I come to the point, what is the example? Basically I will give two examples of refraction. Number 1, twinkling of the star. It is very common in the night time that you all see that the star twinkles. Why? Now the question is, why the star twinkles? Very easy. We all know that the density of air is maximum on the surface of the earth. And as we go upward, the density of the air started to decrease. And as we go high, more high, the density continuously or gradually it becomes less. So as the star is far away from the earth's surface, the light rays that is coming from the star towards the earth's surface, it is traveling from rarer to the denser medium. So while coming from the star to the earth, light rays, it always continuously it is bending towards the normal as it is traveling from rarer to denser. And as the light rays always bending towards the normal while traveling, the apparent position of the star also changes. And as we know, the air is moving, as the air is always moving, so there is a continuous change in the apparent position of the star. And as there is a continuous change in the apparent position of the star, it seems to be twinkling. So this is the first example. Number 2, bending of a pencil or pen or a rod, just like this. If you dip it in a glass of water, obviously the glass should be transparent. Take half glass of water and dip a straight rod or a straight pencil or a pen into the water. What you will see? The pen or pencil or the rod, it appears that it will bend. It is not straight. This is also due to the refraction of light. So this is the best two example you can give for refraction of light. Now I will come to the point. Very important is that what are the laws of refraction. So our next topic is laws of refraction. Laws of refraction. Two laws. First law and number 2, second law. First law. So this is the laws of reflection, first law and second law. First I will discuss about the first law. See here in this picture, this is the incident ray, this is the refractive ray, and this one, it is the normal, and this point is called point of incidence. So the first law states that the incident ray, the refracted ray and the normal at the point of incidence, they all lie in the same plane, that is on the interface. This is the first law. Again I am repeating this. The incident ray, the refracted ray and the normal at the point of incidence, they all lie in the same plane. This is the first law. Next come to the point, second law. Second law, that is also called Snell's law, it states that the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. That is mu, which is called refractive index. So here another important term comes, that is refractive index. So just write the second law mathematically. The second law states that sin I by sin r equal to mu constant. This is constant. And this is called refractive index. Sin I by sin r is equal to mu. It is a constant. So here for refractive index, suppose if I write there 1 mu 2, 1 mu 2 refractive index, this means that it is the refractive index of the medium 2 in respect to 1. Again I am telling, if it is written that 1 mu 2, that means refractive index of the medium 2 in respect to 1. Now suppose I write here air mu glass. What do you mean by this statement? Air mu glass. That means it is the refractive index of the glass in respect to the medium air. What is its value? Its value is 1.5. The refractive index of the glass in respect to air is 1.5 and it is constant for all the glass. Now you may have asked that how this 1.5 come. Just now I will tell about the definition of refractive index. Now come to the point, what is the definition of refractive index? Refractive index states that it is the ratio of the speed of light in vacuum or air to the speed of light in the medium. Again I am repeating, refractive index is the ratio of speed of light in air or vacuum to the speed of light in the medium. So right here, refractive index, it is the speed of light in air by speed of light in medium. Speed of light in air by speed of light in medium. This is the refractive index. Now, here I tell air mu glass, that is refractive index of glass in respect to air. We all know that speed of light in air, that is 3 into 10 to the power 8 meter per second. And speed of light in glass, that is here medium is glass, that is 2 into 10 to the power 8 meter per second. So it will cut, 10 to the power 8 will cut 3 by 2 equal to 1.5. So here comes the value 1.5 in this way. So we are just dividing the speed of light, that is it is a ratio in air 3 into 10 to the power 8 by 2 into 10 to the power 8 meter per second. It will cut, and ratio have no unit. The unit will cut 10 to the power 8, 10 to the power 8 will cut 3 by 2 equal to 1.5. So hope you all understand this refractive index. Lastly, I will come, this is the end topic for today, that is refraction of light in glass slab, through a glass slab. Okay? What happens in this case? Light rays is passing through a glass slab. That means at first the light rays is passing from air to the glass, that is from rarer to the denser medium. As we all know that whenever the light rays passing from rarer to the denser, the light rays will bend towards the normal. Just see this. Again, while it goes from the glass to the air, that means from denser to the rarer, the light rays will deviate or it will bend away from the normal. Just like this. So now what happens? So this is the refraction of light in a glass slab. Now one case, if there is no glass slab, then what will happen? Suppose there is no glass slab, then the light rays will pass straight in this way. This is the path. But as the light rays is passing from here, that is in this way, due to the presence of the glass slab, that means there is a shift, there is a change in the path of the light rays. This is called the lateral displacement. So this is all about the refraction of light through glass slab. Lastly, I will tell there is one application of refraction of light, that is called dispersion of light. But in my next video, I will continue this chapter and I will discuss about the dispersion of light as well as about the different types of lens, convex lens and concave lens. All things I will tell in my next video. So today till this much. Now hope you all understand this, the basic concept of refraction of light. But still, if you have any problem, you can comment in the comment section of my video. And this is my first educational video, and as it is my new channel, YouTube channel, that is Educational World, so please subscribe my channel and share this video to get more and more video like this. Soon I will upload my new video on a new science topic. Till then, bye. Thank you to everyone.